Part 2, Solving Logarithmic Equations. Basic strategy for solving logarithmic equations. First, rewrite the equation in the form log base b of u equals y, or if there's two different log expressions, we could write it as log base b of u equals log base b of v. If at all possible, you want it in one of these forms. And then if we have log base b of u equals y, just change it to exponential form and see if you can solve it from there. If you have log base b of u equals log base b of v, then because the log function is 1-to-1, we can use that property to reduce the equation to just u equals v. And then solve the new equation, find all the potential solutions. Now, they're only potential solutions because each solution has to fit with the domain of the original expressions. So check each potential solution in the original equation. Those that satisfy the original equation are its solutions. The problem will be with the domain. So if we have, say, the domain of the log function in the original equation was, say, x is greater than 3, and then we end up with a solution of x equals 1, well, 1's not greater than 3, so it's not going to work. So that would just not be a solution. And that can happen. We can have these extraneous solutions when we're solving logarithmic equations. So for example, let's solve this equation. We have log base 3 of x plus 3 plus log base 3 of x minus 5 equals 2. Notice both of these logs are the same base, so I could combine this into one log expression. So I have log base 3 of x plus 3 times x minus 5 equals 2. And then I can change this now to exponential form. So I have base 3 to the second power equals x plus 3 times x minus 5. So I have 9 equals x squared minus 5x plus 3x minus 15. Combine like terms, and I get 9 equals x squared minus 2x minus 15. Then subtract 9 from both sides, and I get x squared minus 2x minus 24 equals 0. This can be factored into x minus 6 and x plus 4. So x equals 6 or negative 4. Those are our two potential solutions. Now we need to check and make sure that neither of these solutions causes a problem with the domain. So if I substitute in x equals 6, here I have 6 plus 3, that's 9. 9 is positive, so that works. Here I would have 6 minus 5, which is also positive, so that one also works. So the solution x equals 6 works. What about x equals negative 4, though? If I were to substitute in negative 4 into x plus 3, negative 4 plus 3 is not positive. So that solution is not going to work because we cannot take the log of a negative 1. We can only take the log of positive numbers. So our only solution will be x equals 6. Solve the equation 2 log of x minus log of 2 equals log of x plus 4. Before I can combine the two logs on the left side, I first need to move the coefficient up as an exponent. So this gives me log of x squared minus log of 2 equals log of x plus 4. And then I can combine the left side, so it's all into one log. So I have log of x squared over 2. It's a minus in between, so I use this, combining it into one log with a divide, equals log of x plus 4. Now these are both base 10, so I have the log base 10 of something equals the log base 10 of something, and because this is a 1-to-1 function, that means x squared will have to be equal to x plus 4. Now if I want to get rid of the fraction, I'm just going to multiply both sides by 2. So I have x squared equals 2x plus 8. Then get everything on one side. I have x squared minus 2x minus 8 equals 0. And that factors 2, x minus 4, and x plus 2. So our solutions are 4 and negative 2. Then again, I need to check. If I substitute in 4 for x, then we're taking the log of 4 there. That's totally acceptable. 4 plus 4 is 8. That's also positive. We can take the log of 8. So we're good there. But if I plug in negative 2, then I would be first, the very beginning, I would be taking 2 times the log of negative 2. And negative 2, we can't take the log of that. It's not a positive number. So again, negative 2 is not a solution. Our only solution is 4. Now, it's possible there would be no solution in a problem you get. So check all of your solutions. Maybe they will all work. Maybe some of them, maybe none of them will work. But you'll need to check every single one. Let's try this one. Log base 5 of x minus log base 5 of x plus 1 equals 2. So I'm going to combine the left side into one log. So I have log base 5 of x over x plus 1 equals 2. Then write this in exponential form. So I have 5 squared equals x over x plus 1, or 25 equals x over x plus 1. To solve this for x, I'll multiply both sides by x plus 1. So I get 25 times x plus 1 equals x. Distribute through and I get 25x plus 25 equals x. If I subtract 25x from both sides, I get 25 equals negative 24x. And divide by negative 24, I get x equals negative 25 over 24. Then I check and see if that solution works. So I have to take the log of x, but x is not a positive number, so that's not going to work. So there is no solution to this equation. The only solution we got is not in the domain of log base 5 of x, so there is no solution. Let's try this one. Solve the equation 1/2 log base 2 of x plus log base 4 of x minus 1 equals log base 4 of 4x. Notice not everything is the same base. Can we change this somehow? Let's look at the 1/2 log base 2 of x. So I can write that as log base 2 of the square root of x. X to the 1/2 is the square root of x. And the rest I'm going to leave just like they are. Now I want to change my log base 2 of square root of x to a log base 4. So let's think about this. Log base 2 of square root of x means 2 to some power, we don't know what that power is, equals square root of x. That's what log base 2 of square root of x means. But now notice if I square both sides of that equation, I get 2 squared, or 4 to that same power, equals x. So I could write log base 2 of square root of x as log base 4 of x. Either one would be the same power, 4 to what power equals x, or 2 to what power equals square root of x. And then the rest is already log base 4. Then I can combine the two logs on the left side. There's a plus in the middle there, so I have log base 4 of x times x minus 1 equals log base 4 of 4x. So I have log base 4 of something equals log base 4 of something. I can write this as x times x minus 1 equals 4x. Distribute through, I get x squared minus x equals 4x. Subtract 4x, and I get x squared minus 5x equals 0. Factor the left side, I have x times x minus 5 equals 0. So x equals 0 or x equals 5. Those are my two potential solutions. Go back up to the original equation. If I substitute in 0 for x, then I'm taking the log of 0, which isn't possible. So I know that one's not going to work. What if I substitute in 5? So log base 2 of 5. 5 is positive. 5 minus 1 is also a positive number. And 4 times 5 is also a positive number. So x equals 5 will work. Let's find the inverse of this function. F of x equals negative log base 4 of x plus 2 minus 3. So we have, I'm going to write this as y equals negative log base 4 of x plus 2 minus 3. Then I'm going to switch the x and y and solve for y. So I have x equals negative log base 4 of y plus 2 minus 3. And now I need to solve for y. So I'll add 3 first. X plus 3 equals negative log base 4 of y plus 2. Divide both sides by negative 1. And I have negative x minus 3 equals log base 4 of y plus 2. Now that the log part is by itself, I can write this in exponential form. So I have 4 to the negative x minus 3 equals y plus 2. Subtract 2, and I get 4 to the negative x minus 3 minus 2 equals y, which is the inverse of f of x. So here's the two graphs of those two equations, and we can see they are symmetric about the line y equals x.